For the graphing part of the quiz, we state our objective. Our objective is to graph the rational function. Okay, so there's objective number 1, graph it, and define the stated characteristics. Well, graphing, we have steps. What's step 1? Step 1 is to identify what's the vertical asymptote and what's the horizontal asymptote. Well, our parent function is y equals 1 over x, so we know it's going to look like this. That's what the graph. Oh, there you go. The graph is going to look like that, but it's going to be shifted left, right, up, down, something like that. But how do we find our vertical asymptote? Well, the first thing we should remember is the standard form for a rational function. Basically, standard form, given an h and a k. So in this case, the h is what's being subtracted from the x, and x minus -4 gives us an x plus 4. So therefore, h is -4. If h is -4, the vertical asymptote is x equals -4. Well, x equals -4, we can graph that. That's our vertical asymptote. And then our k value, our k is -2. And if k is -2, that means that y equals -2 is our horizontal asymptote. So we have our lane lines now. And now all we have to do, I'm going to go ahead and be a little bit more specific on this graph. I'm going to go ahead and find the x and y intercepts first. So x-intercept, that's when y is equal to 0. So we're going to go ahead and let y equal 0, 1 over x plus 4 minus 2. So in solving this equation, let's go ahead and set up a proportion. So if we add 2 to both sides, we get 2 equals 1 over x plus 4. Well, it's not a proportion yet until we make the 2 over 1. So now we have one fraction equals another fraction. And if you remember, when we have a proportion, solving a proportion means we're going to cross multiply. The two numbers on each diagonal are going to be multiplied together. So 2 times x plus 4 is equal to 1 times 1, which is 1. If we distribute the 2, we get 2x plus 8 equals 1. Subtracting 8 from both sides, we get 2x equals -7. And when we divide both sides by 2, we get x equals -7 over 2. So therefore, the x-intercept is -7 over 2, comma 0. Make sure you write your x-intercepts and x and y-intercepts as coordinates. So -7/2, that's -3.5. So -3.5 is right there. That's our only x-intercept. So it's going to get a little tight here. It's tough to draw that graph. But then the y-intercept, we know that to be when x is equal to 0. So we solve for y equals 1 over 0 plus 4, which is 4, minus 2. Well, we have two fractions, minus 2 over 1, and then we have to get a common denominator, right? So we multiply top and bottom of this second fraction by 4, and we get 8 over 4, and 1/4 minus 8/4 is -7/4. Well, -7/4 is -1 3/4. So -1 3/4 is right about there. And so now we have our asymptotes and we have our intercepts, and we're going to go ahead and draw the graph. So it's really tight here. In fact, I don't need you to be this accurate. I mean, when I've done these examples before, I've just said, look, just draw the graph and then just add the intercepts later, which is totally fine. But I do need you to understand that the graph continues to get closer and closer to each of the asymptotes, just like it does over here. It doesn't actually touch the asymptote, but if you happen to touch it, you make a mistake, just make it look like that, and understand that the graph never does touch the asymptotes. So we'll get that. We'll see that down here in the chart. Horizontal asymptote, we already said, was y equals -2. Vertical asymptote, again, make sure that you're indicating that the asymptotes are equations. We also talked about the y-intercept here, 0, -7 over 4. And then oh, what was I going to say? Oh, the domain and range. So the domain and range will identify if you say, look, x, all x such that x cannot equal -4. Then I know that you know that the graph actually doesn't touch the asymptote. So even if you touch it by mistake, you get it down here, you cover yourself by saying, look, x can't be -4. And what about the y? If you touch the asymptote there, if you touch the -2, I don't think you think that the graph touches the asymptote if you write y does not equal -2. So here we have just remembering what this means here. This says the domain is all real numbers x such that x does not equal -4, and the range is all real numbers y such that y does not equal -2. Now, for increasing and decreasing, we look at that. We don't see any time where the values are getting higher. So as x increases, the y values are always getting lower. So the decreasing is from -infinity to -4, as well as from -4 to infinity. Yes, it's 1 to 1, because any horizontal line will hit the graph at only 1 point, at the maximum of 1 point. And speaking of maximums, there are no maximums. The graph goes up forever, so there's no max, and it goes down forever, so there's no min.